Creamer Media's Mining Weekly is speaking to Keith Liddell, a highly experienced metallurgical engineer, a director of mining companies, and a person who has introduced a system that could change the face of mining. Keith, could you give me some insight into what has happened with the Kell process since we spoke several years ago?
Certainly we have been extremely busy in essentially engaging the overall PGM industry in Southern Africa, but also to some extent globally, and that's producers and developers. And we've been conducting studies, so feasibility studies, scoping studies, and test work, so batch test work, pilot test, continuous test work. So the industry all is now well informed about Kell, and in specific terms, its operating costs, its capital costs in relation to their own operations. And they're all sitting there waiting for outcome from our first commercial installation. And it's the classic that we always see with new technology into the conservative mining industry. It's don't be first, but make damn sure you're second. And we appreciated that many years ago when we tied up with Sedibelo Platinum and the Pallinghurst Group, and then quickly after that, the Industrial Development Corporation, because we knew we had to have a Kell plant working on a mine somewhere before the balance of the industry would accept that. And Sedibelo particularly is a company that wants to take its Pilanesberg Platinum Mine and vertically integrate that so that it can produce its own PGM metals and base metals at the mine site. So last couple of years, particularly this year, we further optimized the engineering into a fully modular plant format, which has simpler operational characteristics, but also further reduces and optimizes CapEx and operating. And we've also been really firming down the designs for the PGM refining section, and also base metal refining, and looking at options, what you produce from your base metals, whether it is the metals themselves or battery grade sulfates. This year we've been completing an update of the definitive feasibility study for the Kell plant at Pilanesberg Platinum, and we'll actually have that finished next month in time for an investment decision from the shareholders in KellTech South Africa, which is Sedibelo Platinum, Lifezone and the IDC. And we've also been working on the application of Kell for gold, and I'll go into that a little bit more in detail. But we've now got it working on refractory gold concentrates as well as a variation of the basic Kell process. And we've also had, over the last couple of years, 4 new patents granted globally. So we've enhanced the protection of the technology as well. Part of the work we've done is had some independent studies looking at, I guess, the greenness of Kell and in fact the comparison of the CO2 footprint per ounce of PGMs that are produced from the conventional smelting route and from Kell, and also confirming the electricity reductions. So just looking at electricity to start with, I mean, the Reserve Bank of South Africa stated categorically that the electricity shortage in South Africa was one of the most prominent obstacles to a faster economic recovery for South Africa as it comes out of COVID. The current PGM smelting infrastructure consumes a massive amount of energy. In fact, over a year, it consumes 5,000 gigawatt hours. The Kell process consumes 20% of the electricity of smelting. And to put that in context, hypothetically, if we replace all of the smelters in the PGM industry in South Africa, we would save about 4,000 gigawatt hours a year of electricity, which could be released back into the South African energy pool. And to put that into context, that 4,000 gigawatt hours a year is about the size of the Medupi power station. So it could save Medupi. To put that in a global context, Medupi is the 8th largest coal-fired power station in the world. You can imagine the CO2 that emits from the coal in South Africa. So the hypothetical situation is it could save a Medupi in CO2 production as well as electricity. So we've conducted some independent studies looking at the carbon footprint and also the SO2 emissions coming out of Kell. Our CO2 emissions per ounce of PGM produced are only 19% that produced by smelting. So the industry not only is looking at how it reduces its carbon footprint, but also the end users of the PGMs, the auto manufacturers particularly, they're under pressure to reduce the CO2 footprint of the vehicles they produce. So this is a way of the entire value chain through to finished products, reducing their CO2 footprint. Another thing is the South African industry has been putting a lot of the capital recently into removing the sulfur dioxide that goes up the stacks from their smelters and converters, and has been spending billions and billions of rands on that, but they're still not 100% efficient, so SO2 still does go into the atmosphere. Kell process produces zero SO2. All of the sulfur in the concentrates is retained as a solid, as gypsum, which goes back into the tailings dams. So therefore, the SO2 is bound back into a solid form and not emitted into the atmosphere. So from a number of metrics, electricity consumption, CO2 production, SO2 production, Kell has got a much more environmentally friendly footprint on that, and that's independently verified now.
That is amazing. And now let's get to the cost, the capital cost of this. How does this compare?
We've conducted a lot of studies now, probably more than a dozen at various levels, scoping study level, PFS, and then bankable study. And that's for different ore types, Marinsky, UG2, Plat Reef, and then also some work on the Great Dyke in Zimbabwe. And in all cases, capital cost is 1/3 that of a similar sized smelter refinery plant. And again, that's been independently verified by third parties, by engineering companies. And that's to take the product from concentrate, which goes, typically goes into smelters, through to the refined metals. And the operating costs are about 50% of that. So there's a big capital and operating cost saving over time for adoption of Kell into the PGM industry. So the prize is quite big. But also importantly, Kell recovers the metals out of the concentrate into the metal form much faster, in order of weeks rather than months, which is what smelters and refineries do with their big lock-up of pipeline. So that releases a massive amount of working capital tied up in the systems back into the users of Kell plants as well. If you're an existing producer, and this is in the case of the Pilanesberg mine, existing producer that sells concentrate into the existing smelters, if you release the working capital that's tied up in the 5 months pipeline for payment of all the metals back in a month, that is half the capital cost of a Kell plant right there. So you can release the pipeline to help fund the capital cost of Kell plants. On site, you can go within weeks from concentrate into refined metals. You can see the graphic behind me. That is actually the basic layout of the Kell plant at the Pilanesberg mine. Basically, take the concentrate from the concentrate shed, which is just off that slide, about 100 meters into the Kell plant. And what comes out of that plant is refined platinum, palladium, and rhodium, a mixed product that contains a ruthenium, osmium, and iridium, which will go be sold into refinery. Those are the minor metals. It's less than 1% of the revenue. And this plant is also designed to produce copper and nickel as metal cathodes. And we have tacked on the end of it a very small cobalt recovery plant.
What has been happening to that cobalt with the conventional smelting process?
Conventional smelting burns off, in fact, most of the cobalt, and it's lost into the slags, particularly the converter slags, and is lost and is not paid in contracts. So Kell dissolves quite a lot of the cobalt, in fact, up to over 90%. But the levels are so small that it's very hard to pilot a cobalt recovery section in continuous pilot plants. So we know the chemistry, and we've done some smaller scale tests, and we have recovered it into solution, but not into the metals in the pilot plant. So we put a small cobalt recovery plant that takes it through to cobalt metal, but we can also make cobalt sulfate or cobalt hydroxide. And that will be a small test plant for the cobalt recovery in this Pilanesberg mine plant.
Does this way of doing things get you closer to tailor making things for what the market wants?
This plant does, because essentially we have all the PGMs refined into very pure solutions before you precipitate them out, and the base metals as well. And once you've got that, you can actually then form them into any form of material you want. It can be metal powder, it could be briquettes, and in fact it can be the metal salts as well, which then can go into other industries. And we'd like to see this Kell plant actually, and we are having discussions about this one at Pilanesberg, sitting in a special economic zone, which will then attract other industries around that can then form our purified materials into other products. And we have been having discussions with battery precursor manufacturers to start to produce, for example, the battery precursors, nickel, cobalt and manganese, which goes into the battery manufacturing. So we would like to think that this plant could be a hub for vertically adding value through to the consumers, and start to attract that not only into the region around Pilanesberg, but also attract these industries into South Africa. And I think this sort of starts to beg to what I call resource nationalism. And I think we're seeing that around the globe, particularly is let's bring industries back home to where the resources sit, rather than being a quarry or a semi-finished exporter. Let's bring the added value industries back home where the resource sit. And that also starts to create skilled jobs. And I think it's important that plants like this Kell plant at Pilanesberg actually sit on the mine site, because this plant will, when it's in production, create something like 200 skilled jobs in the area. And that's very important to us, at Sedibelo Platinum, where we employ something like 65% of our workforce is from communities less than 5 kilometres away. And we need to be upskilling those people into more added value jobs than just running the mining side or the concentrator side. These are chemical engineering skills and detailed instrument technician skills and those sorts of things. So it's not only the commodity side or the consumer side, it's also uplifting the communities that sit on the mine sites, and historically they haven't benefited much from added value jobs.
What sort of carbon footprint is this plant likely to have?
Current smelting and refining process produces 1.75 tonnes of CO2 per tonne of concentrate fed into the smelters. And if we took that tonne of concentrate and put it through a Kell plant, the Kell process will produce 0.34 tonnes of CO2 per tonne of concentrate. 20% of the CO2 production happens because of Kell over compared to smelting. The acidification coming out of Kell is only 27% per tonne versus the industry. So massive reductions in this. So the ESG component of a company or an industry adopting Kell is massive, and it goes straight to their bottom line, and then would flow through to their scope 1, scope 2 and scope 3 emissions. Interestingly enough, I mean, South Africa has now a carbon tax, and we're in a couple of years into it, and the carbon tax goes like this over the next 5 years. And so smelting and refining is naturally going to become more expensive because of the carbon tax. And if Kell produces only 20%, 1/5 of the carbon emissions, the carbon tax for the companies just by adopting Kell savings is going to be massive as well. The process only dissolves out the valuable metals and the minerals that they are contained in. All of the other gangue minerals, the chromite and the silicates, they're untouched and they just pass through the process. Whereas smelting basically takes the whole concentrate with all the gangue minerals, it heats it up to somewhere between 1300 and 1600 degrees centigrade, and then it melts it all. And so there's a massive energy component to basically melt all of the stuff that you don't need to be touching. So Kell basically takes the current bun and picks the currents out of it and then throws the rest of the bun away, and all you've eaten is the currents. So inherently it's much more efficient because it doesn't change the nature of the gangue minerals, which you don't need to touch to recover any PGMs or base metals out of them.
if one of these plants goes ahead, there could be many more. This could be the starting point.
Hopefully we'll finish our feasibility study next month, and it will go to the various credit committees and boards in December, and probably through into the first quarter next year for funding approval. And Sedibelo and the IDC and some third-party funders have spent the last 4 months actually doing the updated due diligence in advance of the feasibility study being finished, because obviously we've got a massive amount of data anyway that they're reviewing. So then it's about a 24-month construction period, so that takes us 2 years into your 5. Then it's commissioning. So I think in 5 years' time, I'd like to see a few more Kell plants up and running on the back of maybe a year's successful running at Pilanesberg. Then, as a company, our business model is to license out the construction of Kell plants to the industry as owners. So that comes with a technology package, a design package, the engineering package if required, and then the owners then fund it and manage construction and operation of it, and we provide technical support, and it will be at that stage training support. But we're building a big training centre as part of the Pilanesberg plant, initially to train our own operators, but with a view to then using that as a training plant for further Kell plants that roll out. We have our engineering packages. We work closely and in fact exclusively with a Simulus Engineers, an engineering company here in Perth, to develop all of our engineering packages. But gradually that will sort of roll out as a technology package, and the South African engineers, I think, eventually will be comfortable enough to to construct those plants. So we won't be constructing plants at the KellTech South Africa or Lifezone level. That'll be up for the clients themselves to do that, which is what they generally like to do anyway. The plant behind me is about 200 metres that way and 100 metres that way, and that includes a refinery. And we don't have the helipad there at the moment to fly the precious metals off site, but that will include that. And that is something like 1/10 the area of a smelter, converter, base metal refinery, and precious metal refinery. So very compact, and I guess that's the benefit of hydrometallurgy, is we have very fast reaction rates, which means you get small equipment. Water usage is approximately 1 tonne of water per tonne of concentrate, and that's mostly lost through evaporation. The rest of the water is recycled within the plant in the recycle streams. And then, interestingly enough, the tailings from this plant is mixed in with the flotation tailings and pumped to the existing tailings dam. So there is no separate waste disposal associated with this plant, and that's one of the benefits of locating the plant next to the flotation concentrator that makes the concentrate, is the residues from the Kell plant, which is the gangue minerals that haven't been leached, and then the gypsum, which is precipitated, which is the calcium sulfate, so that's the sulfur, then blends back in with the tailings. And the Kell residue by weight is less than 1% of the flotation tailings. And then it's co-deposited back in with the flotation tailings. And we've had all of the standard stability and toxicity tests run on that, and it's a benign, the mixed tailing is benign. It meets all of the international specifications for stability. And then just as another factor, this Kell plant has received its environmental license for construction. So we've gone through all of the environmental hurdles that you have to jump through. It's been a long road for Kell, but as I said, we're putting it into a conservative industry. And interesting enough, I mean, we were almost ready to go with the construction of this plant. It had been board approved at the end of 2016, and then Dieselgate came along, and the industry essentially for a couple of years went into a mode of not spending capital, and that was the feedback we got from the entire industry. With palladium and rhodium prices having re-emerged this year, it's more into a capital expenditure mode. So essentially, we're ready to go with this Kell plant, and we have taken the time really to hone down our engineering and some of the chemistry and the refining side. So nothing's really changed in concept at all. We've just been fine-tuning. And as I said, really focusing on the environmental metrics. Electricity consumption is 20% of smelting. The CO2 footprint is about 20% of smelting. The SO2 is, there's no SO2 emissions from this operation, so there's no acid rain forming. And as we've said, the water consumption is negligible. It produces skilled jobs at the mine site. It produces metals at the mine site. It allows the industry to essentially transition to an environmentally friendly way to produce PGMs. It's essentially a hydrometallurgical process in that the key elements are leached and re-leached. There is a little pyrometallurgical bit in the middle that we put the material through a kiln to render the precious metals leachable again after having taken out the base metals. But we don't melt it, we just heat it up under specific atmospheric conditions. But essentially, the pyrometallurgy, which is the existing smelting, that's the big sledgehammer cracking a nut, and it smashes the walnut to smithereens to try and extract the benefit out of it. What we do is with a pair of nut crackers just open it up and then extract the kernels out. And in doing so, it's much less energy intensive and much less carbon dioxide emitting.
Is there any box that doesn't tick?
We're looking at how we can apply it into other industries. We do get very good results when we look at actually reprocessing catalytic converters. And we're trying to find a market niche for that. We've done quite a bit of work on that. At the moment, they're essentially thrown back into the smelters again. So again, the reprocessing of catalytic converters might sound environmentally friendly, but again, there's a massive carbon footprint to that. So we're focusing on that. And we're looking at other processes that use a lot of energy. So for example, lithium generates a lot of energy, particularly from spodumene. So we're looking at how we might modify Kell for a hydrometallurgical process for lithium. We've cracked the gold. Again, those concentrates are normally smelted, and we can start to divert those away from pyrometallurgy into Kell gold, which is hydrometallurgy. So I guess we've latched on to where do materials have a high CO2 footprint because they're smelted or heated up to very high temperatures. And we're trying to crack those technologies now.
The world is talking about a circular economy.
We've got a plant design for the catalytic converter recycling as well. We've done some scoping studies and engineering studies. But our main focus is on getting the Kell PGM technology pushed out into the Southern African mining industry to get that adopted, and everything else will flow from that. The world is our oyster, but definitely we have a strong South African focus at the moment.
Who are the owners of Kell?
Lifezone is my main IP company that holds the technology, and we have a few number of investors, shareholders there who have supported me now since 2005 in funding. They're people I've worked with in the industry a long time, particularly Mike Adams, who I was at Mintek with in the 1980s, and that's going back a few decades now. And Mike is our chemical engineer on the team, so he's the brains with the chemistry. I'm the nuts and bolts man. And then the license for Southern Africa is owned by KellTechnology South Africa, and that has two other shareholders in it, which is Sedibelo Platinum, who have been supporting us financially and also will be the concentrate provider from the Pilanesberg mine. And then the Industrial Development Corporation has been a very strong supporter financially and morally. And they've been involved in Kell since 2016.
How did you just stumble upon this idea?
My first job at Mintech was at Western Platinum Mines in 1982. So I got exposed to the platinum industry there, and it was actually troubleshooting the first commercial UG2 plant that was built, and it was producing far too much chromite in its concentrate, and it was affecting the smelter at the time, the little circular smelter at Longmin. So I could see the problems that chrome had in the concentrate. And then when I got to Aquarius in the late 90s, and we were trying to sell a UG2 concentrate from Kroondal into an industry that wasn't really interested, one of the options we had to have was a way to process our own concentrate on site, and we were too small to sustain the capex of a smelter, let alone a platinum refinery. So I conceptualized a hydromet process, which is Kell, had test work done to prove the concept, and then came up with an engineering design. In the meantime, we'd also devised a different flotation route, or whole mining and processing route, which meant that we could make, instead of a 300 gram a tonne concentrate, 1,000 gram a tonne concentrate, which, as it turned out, was attractive to Impala Platinum. So Impala gave Aquarius the offtake agreement, which meant that my little hydrometallurgical process then sat on the shelf from about 2000 until 2005, when I relicensed it back from Aquarius, and then really started to focus on Kell itself. So really the focus on Kell has really been from 2005 in terms of the time and effort and energy to take it where it is today. But when I say 5 and count the years, that's 15 years. I think we're coming to the acid test time. So hopefully we will fund the plant and get that into construction. And then, of course, we have to successfully commission it and bring it up to full capacity. And you never fool yourself about how easy that is. But I think the amount of brain power that's gone into it for now is such that we hope that'll be a smooth journey, but time will tell. I appreciate the support I've had from everybody and my shareholders in Lifezone.
That was Creamer Media's Mining Weekly, speaking to Keith Liddell, a metallurgical engineer, mining company director, and a person who is coming in with a Kell process that could make a big contribution to South Africa.